Hello. So I wanted to show you this problem right here. It says three identical blocks are pulled across a horizontal frictionless surface, and T3 is 45 newtons. And I'm going to cross out the question, and I'm just going to find out what I can find out. Okay? Let's get started. So I'm looking at is three masses all connected by strings, right? So I got mass 1, rope T1, mass 2, so I'll call that mass 1, mass 2, and mass 3, I'll call this T2 for rope 2, T1, rope 1, and then it looks like T3 we already know, and I'll draw a little person pulling just so I can have an object actually pulling. Okay? All right, and we know we're given T3, we're given as 45 newtons. So let's see what we can figure out here. If we do a force diagram for T3, all right, for M3. So for this system here, so I'll write M3 system. There's mass 3. Actually, I don't like that. I'm going to make this entire thing my system. So M1, M2, M3 system. So that's everything all together. That's going to work way better. Okay? So I'll have weight going down, right? I'll have normal force going up. Okay? So I'll call this normal force. And I'll have T3 pulling to the right. And it says we have a frictionless surface. Since I can't figure out any force acting on my system to the left, this would have to be constant acceleration to the right. So I'm going to draw a vector to show that. Okay? There's my vector. If I add up my forces, I have normal, I have weight, okay? And then I have T3, okay? Well, I started here and I end here, so that vector is my sum of the forces vector, which is the same length as my T3, which I actually know is 45 newtons. And I also know that this vector has to be equal to my A vector scaled by M. Okay? So I should be able to use that to solve for my acceleration. And my total mass should be 3m. So I'm going to call this my 3m system. Okay? And what we're going to have here is sum of the forces on this 3m system has to equal ma. Now, the net force, the magnitude, is equal to 45. And that has to equal 3 times m. That is m plus m plus m is 3m times a. So A has got to be 45 over 3m. I have no units here. I'm going to get confused. And my acceleration vector therefore has to have a magnitude of 15 over m, whatever m is. Okay? That's about as far as I can go right there. So maybe I should try to figure out what I can figure out from a different system. Okay? If I combine m1 and m2, that would be these two here. Okay? So m1 plus m2 system, I'll get weight pulling down, normal force up, and now I'm talking about T2 to the right, and of course there's no friction, but I do have T1 pulling, no, I don't. I've combined M1 and M2, so I don't have to worry about T1. It's internal to my system. Let's add the vectors. I got normal, weight, and T2, right? So weight, normal, T2. If I draw a new vector from where I started to where I finish, that's my net force vector, my total force, my sum of the forces, my resultant vector. Okay. And we don't know its magnitude yet, but we know it has to equal my acceleration vector scaled by m. Okay. So T2, so sum of the forces again, has to equal ma, the vector equation, and plug in T2 here. T2 has to equal, let's see here, m for T2 is going to be 2m, okay? So it's a 2m system. So all these masses, m1, m2, m3, are identical. That was one of the things that we knew in this problem. Okay, so again, T2 has to be 2m times A. Now I know A is 15 over m, so I'm just going to say 15 over m, because all of these systems have to have the same acceleration because they're all attached by the same by ropes. So they're all going to have exactly the same acceleration. Now this is kind of nice because my T2 now, m is going to cancel. Well, that's what I was hoping for. And I'm going to get 30. And at this point, I'm going to put the units back. 30 newtons. I didn't want to get confused with my m being mass and thinking that's meters or something silly like that. So I didn't have my units in there yet. Now that gives me T2. Now I bet I can figure out more. Maybe I'll make M1 my system now. So this is M1 system. So that's just this little dude down there. Okay, so here, I'm talking about this mass here in our original picture. Just that mass is our system now. And force diagram is going to be weight, right? Normal, yeah. So normal force, weight, and then you got a force to the right, we're calling T1 due to rope 1, okay? And when I add these vectors, I got N going up, weight going down, and then T1 going to the right. T1 is going to be the same length as my net force vector, which is going to equal ma, my acceleration vector, the direction of my acceleration vector, scaled by m. So let's write our second law equation. Sum of forces equals ma, and T1 is going to be equal to the sum of the forces vector. T1 is equal in length to the net force vector, and that has to equal ma, and a again is 15 over m, and again the m's cancel, so T1 has got to be 15 newtons. So it looks like that's a pretty cool problem. If I go back to the original, it looks like we found T3. We knew T3. It looks like we found T1 and T2. Looks like T1 turns out to be 15 newtons of tension in that string, and T2 turns out to be 30 newtons in that string, and then T3, as you already knew, was 45 newtons. And yeah, that's how it works. Pretty cool problem. Pretty nice how it all works out. I hope you enjoyed it. Have a good day.